Have you ever stopped to think about the last meal you cooked? I mean, really think about it. Did you know that you're basically running a series of complex science experiments? Yep, that's right. Your kitchen is a laboratory. And today, we're going to pull back the curtain on the unseen science that turns simple ingredients into something delicious.
I mean, we chop, we heat, we mix, we all know the basics. But what is really going on down at the molecular level? How do all those raw ingredients transform into a culinary masterpiece? Well, let's dive in and find out.
And this is the central idea for our explainer today. We're going to look at your kitchen through a completely different lens, a scientific one. We're going to reveal the fascinating processes that create all the flavors, textures, and aromas that we know and love.
Okay, so we're going to break it all down into three fundamental types of changes: physical, physicochemical, and chemical. Now don't worry, those names might sound a little intimidating, but we'll break down exactly what they mean with simple, everyday examples. Let's get started.
All right, first up, let's talk about physical changes. These are by far the most straightforward and familiar things that happen in your kitchen every single day, whether you're making a simple salad or, some kind of gourmet meal. The key here is that you're only changing the food's appearance or its texture. You're not changing its fundamental chemical makeup at all. It's kind of like giving your ingredients a makeover. They still have the same personality on the inside.
For example, when you chop a carrot, what do you have? You just have smaller pieces of the same carrot. No new substance has been created, you've just altered its form. It's that simple.
Or think about melting butter. It's another perfect example. It changes from a solid block into a liquid, but it's still butter, right? And if you pop it back in the fridge, it'll solidify again. That just shows you how reversible many of these physical changes really are.
And you're probably doing these things all the time without even thinking about it. Freezing water into ice, slicing an apple, tossing a salad, kneading dough, even sieving flour. In every single case, you're just changing the food's form, not its actual chemical identity.
So to sum it all up, a physical change is basically just a temporary makeover for your food. Its core identity stays exactly the same, and a lot of the time, you can even reverse the process.
Okay, let's move on to something a little more complex. We're going to talk about what we're calling physicochemical changes. Now, these are the in-betweeners. They involve both physical and chemical stuff happening that alters a food's texture and structure in some really interesting ways.
So, if melting butter is a simple physical change, then thickening a sauce is a physiochemical one. You can see it's a more complex transformation of the food's internal structure, and it's not nearly as easy to reverse. You can't just unthicken a sauce, right?
It's a trick every cook knows, but have you ever really wondered about the science behind it? How does a simple white powder just magically transform a thin liquid into this rich, luscious sauce?
Well, the process is called gelatinization. When you heat starch in a liquid, its tiny little granules soak up water and they start to swell up, almost like tiny balloons. And as these swollen granules get tangled up with each other, they make the whole liquid thicker. Pretty cool, huh?
Making mayonnaise is another fantastic example. You know, oil and water, or in this case oil and lemon juice, they just do not want to mix. But the egg yolk comes in and acts as an emulsifier. It's like a peacemaker that brings them together to create that smooth, creamy sauce.
Oh, we've all been there. You have this beautiful, fresh loaf of bread, and then the very next day, it's tough and stale. Well, it's not just about it losing moisture. There's actually a fascinating scientific process at work.
The culprit has a name: retrogradation. As the bread cools down, the starch molecules that all swelled up during baking start to realign themselves, and in the process, they squeeze out water. That's what makes the bread become firm. But here's a little kitchen hack for you. Gently reheating the bread can temporarily reverse this, making it soft again.
And now, for the most transformative changes of all, chemical reactions. This is where the true magic happens in the kitchen. This is where simple ingredients are completely remade into something brand new.
Unlike all the other changes we've talked about, a chemical reaction creates entirely new substances with completely new properties. And this transformation is permanent. It's irreversible. I mean, you can't unbake a cake, after all. That irresistible smell of freshly brewed coffee, the perfect golden brown crust on a loaf of bread, the sweet, nutty flavor of caramel, all of that is the result of chemical reactions. This is where simple ingredients are transformed into culinary delights.
Let's just take a quick look at 3 common ones. Caramelization, well, that's what gives us that delicious, toasty flavor when we heat sugar.
Fermentation uses helpful little microbes to give us everything from tangy yogurt to fluffy bread. And oxidation, that's why a sliced apple turns brown when you leave it out in the air. In every single one of these cases, new substances are being created.
So we've explored the 3 fundamental types of food transformation. Now it's time for you to embrace your inner kitchen scientist.
So, here's a quick recap of what we've learned. Physical changes, like slicing a carrot, usually reversible, and no new substances are made. Then you've got physicochemical changes, like thickening a sauce, often not reversible, but still no new substances. And finally, chemical changes, like baking a loaf of bread, definitely not reversible, and you are absolutely creating entirely new compounds.
You see, understanding the science behind cooking really empowers you to be a more creative and confident cook. You're no longer just following a recipe, you're actually using scientific principles to create delicious food.
So the next time you're in the kitchen, I want you to think like a scientist. Observe the transformations that are happening right in front of your eyes. What new culinary experiments are you going to try? The possibilities, my friends, are endless.